We have another example on the board. First, we have to find Z total. In order to find Z total, I'm supposed to find first the capacitive reactance. Please notice that we have given omega and we have given capacitance, so we can very easily find capacitive reactance. So if X of C is equal 1 over omega C. This is equal 1 divided by omega 1 times 10 to the 6 radians per second times capacitance, which is equal 10 nanofarads. This is equal 100 ohms and angle of negative 90 degrees. Please keep in mind that capacitive reactance goes always with angle of negative 90 degrees. Next, we're supposed to find Z total. Please notice that we are talking about the parallel circuit and we have two components connected in parallel. So it means that I can use the formula called product over the sum. So if Z total is equal R times X of C over R plus X of C, which is equal, resistance is 200 ohms times X of C, which is equal 100 ohms and angle of negative 90 degrees. You cannot forget about the angle, over 200 ohms plus 100 ohms and angle of negative 90 degrees. This is equal 89.44 ohms and angle of negative 63.43 degrees. Okay, so this is my Z total. Now, if I have Z total and I have given voltage source, I can find I total. So I have I total equals voltage source over Z total. Please notice that I have given voltage source peak. So it means that the currents which I'm going to find are going to be also peak, and also the voltages are going to be peak. If you will need, for example, RMS values, you're supposed to simply multiply voltage peak by 0.707 and you will get RMS. But in this problem, we are going to find all peak values. Okay, so I have voltage source equals 25 volts over Z total, which is equal 89.44 ohms and angle of negative 63.43 degrees. This is equal to 79.51 milliamps and angle of 63.43 degrees. This is the total current which will flow in my circuit. Okay. Next, we're supposed to find the current which goes through the resistor. IR is equal voltage across the resistor over resistance. But please notice that we are talking about the parallel circuit. In parallel circuit, the voltages across each component are the same. So we can say that voltage source is equal voltage across the resistor, and this is voltage also across the capacitor. So VR is equal, in this case, 25 volts over resistance, which is equal 200 ohms. This is equal 125 milliamps. Okay, this is the current which goes through the resistor. Next, we're supposed to find the current which goes through the capacitors. IC is equal voltage across the capacitor over capacitive reactance. So I have 25 volts over the capacitive reactance, which is equal 100 ohms, an angle of negative 90 degrees. This is equal 250 milliamps, an angle of 90 degrees. Someone is going to say, okay, we can continue. We can go to the voltages or power factor. Okay, we can go, but it's always good to check if our answers are correct. We're supposed to verify these answers by using KCL, Kirchhoff current law. Kirchhoff current law says that the total current in this circuit will be equal to the sum of currents which go through each branch. So I'm supposed to write I total is equal IR plus IC, which is equal 125 milliamps plus 250 milliamps, an angle of 90 degrees. This is equal 279.5 milliamps and angle of 63.43 degrees. Okay. Please notice that the value of current which we obtain is the same to the one which we get from division of voltage source by Z total. So we can say that these two values of current are correct. Now we can continue. We found already voltages across the capacitor and across the resistor. We said that they are the same because this is parallel circuit. So I'm supposed to say that all of them are equal 25 volts. Next, we're supposed to find the power factor. Power factor is equal cosine of angle theta, the angle which is next to Z total. So I have cosine of angle negative 63.43 degrees. This is equal 0.447, and I'm supposed to write lead. Why am I supposed to write lead? Because the angle has negative sign, or simply you're supposed to understand that the current, total current in this circuit is going to lead the voltage source by the angle of 63.43 degrees. Next, we have to find the true power. So I have formula, true power is equal 1/2, and I have VR, voltage across the resistor, raised to the second power over the resistance. In other words, I can say this is equal to VR square over 2R. Okay. Now, again, let me remind you, we have to use 1/2 because the voltage source is expressed as a voltage peak. Anytime we are going to use peak values to calculate the power, we're supposed to always write 1/2. We don't have to write 1/2 when we use the RMS values, but at this moment we have to use peaks. So I have voltage across the resistor. Voltage across the resistor is equal to 25 volts raised to the second power over 2 times R, which is equal to 200 ohms. Everything is equal 1.56 watts. This is my true power. Next, we're supposed to find the reactive power. QC is equal 1/2, and I have voltage across the capacitor raised to the second power over the capacitive reactance. This is equal voltage across the capacitor raised to the second power over 2 times X of C, which is equal 25 volts raised to the second power over X of C, which is equal 100 ohms, of course, times 2, is equal 3.12 volt ampere reactive. So this is my reactive power. Next, we're supposed to find the apparent power. S is equal 1/2, and I have voltage source raised to the second power over Z total, which is equal voltage source raised to the second power over 2 times Z total, which is equal 25 volts raised to the second power over 2 times Z total, which is 89.44 ohms. This is equal 3.49 volt amp. Okay, next we're supposed to find the series equivalent circuit to the one which we have given. So what you're supposed to do? You're supposed to simply write Z total is equal, we found this, 89.44 ohms and angle of negative 63.43 degrees. In order to find the values of resistor and capacitive reactance for my series equivalent circuit, you're supposed to simply convert this complex number to the rectangular form. And you will obtain 40 ohms minus J 80 ohms, where the real part is my resistance and the imaginary part is my capacitive reactance. So now we can draw the circuit. So we have voltage source, which is equal 25 volts peak, right? And of course we have omega. We have also resistor and we have capacitor, where resistor has value 40 ohms and capacitive reactance is equal 80 ohms. Now we can say that the problem is solved.